So basically, yeah, good afternoon all of you. So here, this is my project. This is my term paper. It is the automated database prediction term paper that's been presented by Sosa Ivan. Yeah, Sosa Ivan, as you can see, Stream Makerere University. So basically, this is the content of the presentation. I have the introduction, the problem statement, the background of the project, the objectives, the discussions, the case study, the conclusions. I have the findings, the references, and some acknowledgements. So basically, my introduction is that diabetes, one of the most, these are one of the most chronic diseases that are basically affecting individuals, whereby individuals are having high sugar levels in their blood for a prolonged period of time. So it is basically spread. It is best it spreads rapidly, basically in individuals of all ages, but most probably it is most common in females between the age of females of age of 35 and above. So this chronic disease, it is a result of the failure of the body cells to produce adequate insulin, resulting into what? Individuals having high blood sugar levels or low blood sugar levels. So some of the symptoms are we have increase in thirst, hunger, persistent weight loss, and then frequent urination. So basically, the problem statement is that as the number of individuals acquiring database is rapidly increasing every single day. So I have basically this is greatly affecting individuals, losing their lives as well as attaining long-term injuries in their bodies, whereby they are attaining permanent injuries, whereby one is required, whereby individuals are undergoing surgeries, and certain body, some of their body parts are cut off. So with artificial intelligence, I'll be able to diagnostically predict whether the patient will have diabetes at the early stages before it worsens. So basically, this means that artificial intelligence, we use artificial intelligence to look beyond real time and predict whether the person has what? Diabetes or not. So the background of the project is that a diabetes mellitus it's basically, it is the same as diabetes, but it is divided into basically 3 categories. I have type 1, type 2, and gestation diabetes. So basically by type 1, I have type 1, type 2, and what? Gestation diabetes. So this, it is, so like I've said, this diabetes is a result of what? High levels of what? Blood sugar levels with the failure of the what? Body cells to produce adequate insulin that is required within the what? Within the body. So the high sugar levels may result into uncontrollable diabetes in the long run. Yeah. So the objectives of my project is that, one, it is to determine the performance of these classifiers in the predicting diabetes. Yeah. Then basically these are objectives of my study. It is to determine the performance of these classifiers. Yeah. So the classifiers in what? In predicting diabetes, it is to to implement those classifiers that are rare and not commonly used. MLSL, it is machine learning what? Classifiers on the primary data set to analyze their performance. Also to create a unified repository that researchers can refer to when they want to predict diabetes. So this is basically my term paper is going to act as a reference point, whereby researchers are going to be able to use it as a reference point to predict for if someone wants to predict the occurrence of diabetes. Yeah. So basically my discussion is that, so I talked about my data set. Basically the data set that I used, it was the primary data set, and the data set from the UCI, which was these data sets have been commonly used in more than 10 studies. So they basically contain the BMI, the diastolic blood pressure, we have the plasma glucose concentration, we have the skin fold thickness, we have diabetes degree functions, we have the age, the family background, the family history of the diabetes, regular diet, and what? Physical activity. So basically, despite having all these samples, so these are the different data sets have different couples of attributes, so and have a strong impact on the prediction of diabetes. So this is so these are data. This data set, it is a key. It is a keyword. It is a key. It's a key point in what for researchers during the prediction of this diabetes. So I have then I will talk about the diabetes prediction based on the machine learning or deep learning techniques. So basically here we have different machine learning techniques, right? Whereby I talked about the artificial neural networks, the support vector machine, the decision tree, the naive Bayes. These are one of the machine learning techniques or deep learning techniques that are commonly used. Yeah. So based on the study I carried out to predict diabetes. Yeah. So these algorithms that are used to predict so these different algorithms that were used in the predicting in the doing the prediction of diabetes obtain different results. By results I meant different accurate rates, whereby artificial intelligence, whereby the artificial neural networks, I obtain around 60 to what 60% to 60% and 95%. The support vector machine, I obtain 60% to what to 96%. The decision tree, I obtain around 73% and 88%. The naive Bayes, I obtain 76% and what? And 96%. So basically the case studies that so I carried out different things: data collection, I did data pre-processing, then I carried out implementation of the results, sorry, I have the discussion, yeah, further discussion about what I did. Yeah, so basically by the data collection, most of my data that I use, I got it from the Prima Indian data set, which has been employed. It's what I employed in my investigation. So this I also used the UCI machine learning repository. This is where I gathered the data, as well as so this data set is more I'm the original source is the what? Is the National Institute of Diabetes, National Institute of Diabetes, Digestive and Kidney Diseases. That's where I got this data from. So basically data pre-processing. Here so basically I was able to utilize the Panda software packages. So these involve the three data processing strategies that I made to utilize. So this enabled me doing data filtration, aligning, profiting, data reshaping, merging data sets, doing data training and what? Testing. So basically the implementation and the results. Yeah. On the implementation data sets, these classifiers I evaluated different classifiers using is it the Panda software? Yeah, based on how well these so based on how well they worked with the data set. So the classifiers were chosen. So I basically obtained the accuracy, the perception, the recall, the off measure, and the what and the CLO area for each classifier. So basically this caching involves the use of various high performance techniques. So I use the RIP tree. This basically stands for what? For reduces error pruning, whereby I obtain the accuracy rate of 74.48%. Then I use the M5P. That stands for mount variate regression, whereby I obtain 97.17%. So 97.17%. Eh? 90, sorry, I obtained 97.17%. Sorry, Ctrl Z. Let me edit it. It is a comma. 73% and what 88%. Yeah. Then I have the SMO classifiers. Then SMO class, which stands for optimization of the support support. So no, basically this ensures optimization of the support vector machine, whose accuracy rate is 72.14%. Then some of the illustration that I tried to so these are some of the implementation results that I obtained. Yeah. Then I have the basically my conclusion. It is to improve the perception of the database prediction. So researchers have driven to set various classifier types to create new models. So the similar strategy that was used in this paper. Yeah. So I used the same similar strategy in this paper to achieve a greatest forecast accuracy. So we examined the accuracy. I examined the accuracy and the usage of the pattern of all machine learning or deep learning techniques or classifiers for the various couple of years. So using the Prima Indian dataset, the machine learning classifiers with 1 or 0 frequency, and I was able to establish a recommendation for the use, whereby I obtained accuracy rate of 68% to 74%. So basically, this research, I never received any external fundings as I was carrying it out. Sorry. So my future work will be that I'll be able to use the non-use classifiers, the classifiers that I haven't used during this STEM paper. I will be able to use the non-use classifiers in a combined model to enhance the further accuracy of during the prediction of this diabetes, during the prediction of what diabetes. So basically, these are my references. I was able to correct this. I was able to obtain 20 references. Yeah, from the year 2020, from the year 2020 to the year 2021. They're the one that I was able to use. Yeah, thank you, everyone.